Welcome back to the deep dive. Today, we're taking a really deep plunge into the core intelligence you need to run a modern integrated security operations center.
That's right. And we're being really specific today, focusing on the Forti stack. FortiSIEM, FortiAnalyzer, and FortiSOAR.
And this isn't just theory, right? We've pulled out some, let's say, critical insights from sources that look at the NSE 7 SOCAR 7.6 track.
Exactly. The idea is to take about 10 of
Yeah.
these little knowledge nuggets, really, that come from real-world scenarios and turn them into a clear picture of how a top-tier SOC actually gets built. We want you to see the why, not just memorize the what.
I love that approach. It's like using these points as a roadmap, and they break down pretty cleanly into the full life cycle, hitting four main areas. First, you've got your high-level SOC concepts. Then second, the actual detection capabilities. Third is where it gets complex, with ESOCAR incident handling and threat hunting. And finally, the real nuts and bolts of ESA playbook development.
It really shows that you can't just be an expert in one thing anymore. You have to understand the data logistics in the SIEM, the intelligence piece in the analyzer, and then the execution in SOAR.
If one of those is off, the whole thing kind of falls apart.
The whole security posture suffers, yeah.
So our mission today is to connect those dots. We want to show how a choice you make over here in one platform has a direct impact on how fast you can respond over there. Okay, let's unpack this. Starting with getting the data in the first place. So, FortiSIEM. This is your data aggregator. And a problem that comes up all the time, and we see it in our source material, is trying to get critical data. I'm talking file integrity monitoring, FM, deep performance stuff from a Windows server.
Right, but the server is hardened.
Exactly. Standard WMI, Windows Management Instrumentation, is completely blocked for remote access because of internal security policy.
This is such a classic problem. It's a real architectural choke point. Security teams, they block remote WMI because it's so powerful. If it gets compromised, an attacker can learn way too much.
But then you're blind. If you block it, how do you get the compliance data you need? Syslog and SNMP, they just don't go deep enough for something like FEM.
They really don't. You can't get those forensic level details.
So if your normal remote tools are out, what's the definitive Fortinet solution for this exact visibility gap?
The answer you need is the FortiSIEM agent. And the reason it's the right answer, the only answer really, is its operational independence.
Independence. Okay. What do you mean by that?
Because the agent is installed locally, right on the Windows host itself, it doesn't need to make a network call with WMI. It just bypasses that whole restriction.
I see. So it's already inside the perimeter, so to speak.
Precisely. It can grab all that sensitive system-level data registry changes, process activity, you name it, and then it securely forwards it out to the SIEM. You maintain full visibility even in these super lockdown, zero-trust parts of your network.
That makes a lot of sense, but there's a trade-off, isn't there? I mean, you have to manage an agent on every single one of those machines. That's a lot of overhead.
It is. You absolutely wouldn't do this for every log source. It's a targeted solution. You deploy the agent where you have an absolute critical need for that deep data.
Like for specific compliance rule, maybe PCI DSS or something.
Exactly. You accept that management cost because the need for that granular visibility on your most critical assets is just, it's non-negotiable.
Okay, so shifting from how we get the data to how we prioritize it. A big part of optimizing at SOC is entity-based monitoring, which brings us to the watch list feature in FortiSIEM. This isn't just a simple blacklist, is it?
Oh, not at all. A blacklist is reactive. The watch list is proactive. It's a tool for prioritized vigilance. Its main job is to keep a very close eye on specific high-risk things you've already defined.
So we're talking about things like C-level executive accounts or maybe your domain controllers?
Yes, or critical databases with customer data. These are the crown jewels.
So it's not about blocking them, it's about highlighting their activity.
That's the perfect way to put it. Think about it. A regular user accesses a sensitive file. Maybe that's a low priority alert. But if a privileged admin, someone on your watch list, does the exact same thing, that alert needs to be at the top of the queue instantly.
Because the potential for damage is so much higher.
It's all about risk context. The watch list lets your SOC apply a different set of behavioral rules to the entities that matter most. It helps you cut through the noise and focus on what's truly a high-risk deviation.
Okay, so once we've got our data and we know what to watch, the next big challenge is turning all that raw information into something, actionable. And that brings us to FortiAnalyzer.
This is where we start telling a story with the data. And our source material has a great question about customization. Let's say you need to build a custom chart in FortiAnalyzer, but for log data that isn't in any of the default templates. What's the one thing you must do before you can even start designing the chart?
You can't just start painting. You need a blueprint first. The sources are really clear on this. You have to configure a data set.
Exactly. And this is where that precision engineering comes in. A data set is not just a simple filter. It's an object that defines the literal SQL query.
Ah, so it's the raw instructions.
It is. It tells FortiAnalyzer, in very technical terms, which logs to read, which fields to grab, how to group everything, and what filters to apply. If you try to build a chart without defining that data set first, your chart has no reliable source of truth.
That implies a pretty high skill level, though. An analyst needs to know their way around SQL to build these advanced custom reports.
They do, but it guarantees consistency. Once you create and validate that data set, you know the query is sound. It can be reused everywhere, in multiple reports, on different dashboards, in scheduled tasks.
So every analyst is working from the same playbook.
The same scientifically accurate data source, yes.
This idea of moving from structured data to real intelligence, it leads us right to behavioral analysis. Another question in the material is about the feature that spots behavior that's, well, just weird. It deviates significantly from historical baselines.
All right, we're moving beyond static rules here. A simple threshold might be, alert me if disk space is over 90%. That's rigid. We're talking about anomaly detection, which is dynamic.
Can you break that down a little more? I mean, if both of them flag a spike, why is one so much better?
Because anomaly detection builds a statistical profile over time. It learns what normal looks like for that system. It knows about daily peaks, weekly cycles.
Okay.
So it can tell the difference between a totally normal spike in VPN traffic at 9 a.m. on a Monday and a really suspicious surge of outbound data at 3 a.m. on a Saturday. It flags the second one because it breaks the historical pattern.
So it's perfect for spotting unknown threats. You don't need a signature for bad. You just need to spot what isn't normal.
That's the engine of behavioral analytics right there.
Mm-hmm.
But, and this is important, it really depends on having good, clean data to build that baseline in the first place. If your baseline period is chaotic, you're going to get a ton of false positives.
Right. Garbage in, garbage out.
That
focus on immediate threat ID brings us to the next logical step, execution. If FortiAnalyzer tells us what's wrong, FortiSOAR is all about how we fix it, instantly and consistently. Here's where it gets really interesting.
This is all about efficiency at scale. When an anomaly gets flagged, you might get a whole list of artifacts. 50 suspicious file hashes, maybe a dozen malicious IPs.
Which is where efficiency becomes critical. If your playbook needs to do the same thing for all 50 of those, like look up an IP's reputation, you don't want to build 50 different steps. So what's the playbook step that handles that kind of batch processing?
For that kind of clean, scalable design, you have to use the routine step for each loop step. It is absolutely fundamental.
So you define the logic just once.
Just once. And the loop iterates through your whole list, every IP, every hash, whatever it is, and applies that same logic to each one automatically.
Yeah.
It makes your playbook so much easier to maintain.
That makes sense. That handles events. But what about just routine stuff?
What's that?
System health checks, things like that. If a playbook has to run every morning at 8 a.m. no matter what kind of trigger do you need?
That's a scheduled trigger. The key difference is you're basing it on time, not on a system event like an alert being created. Scheduled triggers are for all your recurring operational tasks. Daily reports, nightly backups, routine maintenance. They live outside the chaos of incident response.
Okay, now let's talk about the line between automation and, well, human trust. Automation is fast, but some actions are just too sensitive to let a machine do on its own.
Like resetting a user's password.
Exactly. If the playbook needs an analyst to physically verify a user's identity before it resets their password, how do you build that pause right into the workflow?
That requires a manual input step. It's a hard stop. The playbook halts completely and waits for a human to review the data, make a judgment call, and give it the green light.
But doesn't that slow everything down? I thought the whole point of SRR was to be instant.
Speed is critical, but control is non-negotiable for high-impact actions. You accidentally reset your CEO's password 2 minutes before a board meeting without verification.
Yeah, that's not a good day.
The operational damage from that mistake is way worse than the few minutes you saved. The manual input step gives you that human oversight and a clear audit trail for any sensitive or irreversible actions.
Speaking of control, what about safety during development? The material asks how you can test a new playbook's logic, all its conditional branches and so on, without actually running it against your live production systems.
This is how you make sure it works before you unleash it. You use mock output.
How is that different from just having a separate test environment?
A full test environment is great, but it's a lot of work to set up and maintain all those external systems, firewalls, APIs, everything. Mock output is much leaner. It lets you simulate the response from an external system.
So you're basically telling it what to expect.
Exactly. You can force a step to return a result like IP blocked successfully or threat score, 90, without ever touching the real firewall or calling the real API. It allows for super fast, iterative, and totally risk-free testing of your logic.
That's pure efficiency. Okay, let's switch to data structure within SOAR. There's a question about the feature that connects multiple alert records to a single, bigger incident record. What enables that?
That's done with module relationships. In FortiSOAR, everything is a module: alerts, incidents, artifacts. The relationships define how they connect. You can have a one-to-many relationship where one incident ties together many different alerts.
And without that, an analyst would just be staring at a big, messy list of alerts with no context.
They'd be completely lost.
Yeah.
The relationship is what builds the cohesive story of the attack. It's what turns alert management into true case management.
Got it. And for our last point, let's talk about optimization across the whole SOAR platform. The final question is about the main benefit of using global variables.
Global variables are your central configuration library. They store all the reusable parameters that every playbook might need to access. Things like API keys, server URLs, important IP ranges.
So the main benefit is simplifying updates.
Dramatically simplifying them. If a critical API key changes, you update that global variable in one single place. And that change is instantly available to every single playbook that uses it. No more hunting through dozens of workflows to make one change.
That sounds incredibly useful, but it also sounds a little risky. Putting all your secret keys in one place. That sounds like a single point of failure.
That is a vital question.
Yeah.
You have to balance the efficiency with very strict security. Those global variables are stored in FortiSOAR's secrets management system, and you have to lock them down with tight, role-based access control.
So not everyone can see or change them?
Absolutely not. You centralize the configuration for efficiency, but you decentralize and enforce the access controls to mitigate that risk. It's an architectural choice that requires really good security hygiene.
Leaves us with a final thought for you to think about. In a landscape where response time is measured in seconds, how do you continuously redefine that critical line between trusting your automation and demanding human intervention, all without slowing yourself down?
That decision, where you place that manual approval step, that human veto, is arguably the single most important architectural choice in any automated security workflow.
Something to think about. Where would you put that vital pause button in your own organization? We'll see you for the next deep dive.